Alright, so we're going to be doing a 2-sample t interval from the 2004 AP Stat Test Form B number 4. The question gives you this data table and asks you to estimate the difference in mean time spent on homework for all 6th and 7th grade students in the school by using an interval. Be sure to interpret your interval. So, you must recognize that this is a 2-sample t interval because they give you 2 samples, 6th and 7th grade students, with means, not proportions. So that's how you know it's a t-test. Okay, so filling it in, x bar 1, we're going to use, x1 is going to be used for 6th grade students and x2 is going to be used for 7th grade students. So x bar 1 is going to be 27.3. Standard deviation of the first sample is 10.8. And in the question it said that each sample was 20 students. So x bar 2 is going to be 47.0. The standard deviation of the second sample is 12.4, and the sample is also 20 students. Alright, given that, we must identify what x1 and x2 are. x1 is the true mean time spent on homework by 6th graders. X bar. X bar 2 is going to be the true mean time spent on homework by 7th graders. Alright, once we fill this out, and you've recognized this 2-sample t interval, you must state the conditions for a 2-sample t interval. The first condition is that there are 2 SRSs grouped by the grade levels. The second conditional is an optional condition for t-tests, but it's recommended that you write it, that the population standard deviation is unknown. Third condition, it's stated in the problem that the population is normal, so you could say population is normal based, it's stated in problem, as stated in problem. And the fourth condition is the 10% condition. So you can either combine it or leave them separate. So I'm going to leave them separate. So I'm going to say it is reasonable to assume that there are more than 200, because you have to take multiply both populations, both samples by 10, both sample sizes by 10, so there are more than 200 6th graders and also more than 200 7th graders in the school. Alright, once you've met all the conditions, you can say, since the conditions have been met, we can perform a 2-sample t interval with blank degrees of freedom. You obtain the degrees of freedom by performing the confidence interval in the calculator. You plug in these 6 data values and you keep the confidence level at 0.95 because it asks for a 95% confidence interval. So once you plug in all these data values, the calculator will tell you that the degrees of freedom are approximately 37.297. Alright. So once you've met all the conditions, you can write down the explicit formula for a 2-sample t interval, which is first sample minus the second sample plus or minus critical t value, and then the square root of the sample standard deviation of the first sample squared over the sample size of the first sample plus the standard deviation of the second sample squared plus over the sample size of the second sample. Alright, so once you've written this down, you can start filling in the data values for all of it. So you're going to get 27.3 minus 47.0 plus or minus. So you have to do, to get the critical t value, you're going to do inverse t 0.975 because of the 95% confidence interval, so you have to go in between, and you're going to plug in the degrees of freedom, which is 37.927, and the critical t value you should get is 2.03. Alright, so once you've obtained this critical t value, you can plug it into this equation and then continue filling out the data values. So you're going to get 10.8 squared over 20 plus 12.4 squared over 20. So then you're going to have 27.3 minus 47.0 plus or minus 2.03 now once you've multiplied everything out, because you don't have to show everything, once you've plugged in all the numbers, you can just show the right side, which is going to give you 7.448. So this comes out to be negative 19.7 plus or minus this value. Once you subtract, you get the lower end of the confidence interval, which is negative 27.148. And when you add, you get the upper end, which is negative 12.252. So once you've obtained your confidence interval, this is the confidence interval. It's critical that you interpret it. So this tells us that we are 95% confident that the true mean difference in time spent on homework for all 6th, and 7th grade students is between negative 27.148 minutes. You plug that, you get that from here, and negative 12.252 minutes. Since we use 6th graders as the first sample and the 7th graders as the second sample, and you got negative for both ranges, that indicates that 7th graders spend more time on homework. Okay, so part B to the question asks you, gives you a scenario that an assistant principal reasoned that a much narrower confidence interval could be obtained if the students were paired based on their responses. Is the assistant principal correct in thinking that matching students in this way and then computing a matched pair's confidence interval for the mean difference in time spent on homework is a better procedure than the one used in part A? Tells you to explain why or why not. So, we're going to say that it is not reasonable to pair the data using the method proposed by the assistant principal because pairing data must be done prior to collecting the samples. Oh, pairing. Hold on. This should be data. This should be samples. Alright. If you do all of this for this question, you should be able to get all 4 points on the AP scoring.